Okay, in this video, we'll be solving this 1997 AP Calc BC multiple choice graphing calculator required portion, okay? I'll try to solve it all in one video. I think it might be doable, but let's see how we do on time, okay? We have number 76, which the following sequences converge, okay? So we just want to take the limit as n goes to infinity of all these guys. Okay, the first one, we can already see that it will converge to 5/2. Remember, my quick way to do it, horizontal asymptote. The degrees are the same, take the ratio of the leading coefficients. That's 5/2. This guy, you'll know that, well, when you plug in n is infinity, oh, by the way, you can do L'Hopital's rule over here also, because when you plug in n is infinity, it'll be infinity over infinity, so you could do L'Hopital's rule, which would be derivative of top is 5, derivative of the bottom is 2, so 5/2 also, okay? This one, when we do L'Hopital's rule, because once again, when we plug in infinity, the top e to infinity is infinity, the bottom is also infinity, so indeterminate, we can use L'Hopital's rule. Derivative of the top would be e to n, derivative of the bottom would just be 1, so as n goes to infinity, e to the n would go to infinity, okay? You could also by intuition know this by knowing that the exponent increases much faster than this linear guy could ever do, okay? I can't think what it's saying right now, but exponent increases much faster, so that will dominate as n gets bigger. And finally, we could do L'Hopital's rule here once again, so let me actually work this out. Limit as n goes to infinity, I'll do one of them out, e to the n over 1 plus e to n. Again, when n is infinite, we get infinity over infinity, so we can do L'Hopital's rule. So we get e to the n over e to the n. These will cancel to a 1, so this is 1. So only 1 and 3 converge. Quite easy, okay? When the region enclosed by the graphs y is x and y is 4x minus x squared is revolved about the y-axis, volume of the solid generated is given by what? So this is a little involved. We know how this looks. We know this is a parabola that opens downward, so we have a general idea how it looks. It might be helpful to find the points of intersection, okay, and it might be helpful to find where this crosses the x-axis, okay? When it crosses the x-axis, we can just rewrite this as x times 4 minus x. So we know that there are zeros when x is 0 and x is 4, okay? Now for points of intersection, we set them equal to each other. So x is equal to 4x minus x squared. So 0 is equal to 3x minus x squared. Once again, we can factor out an x. So we know that we have points of intersection at x is 0 and x is 3. So we can now sketch this, okay? So we know how this looks. That's very easy. It's a straight line, okay? This we said is a parabola that opens downward. There's a point at 0, 0. And there's an intersection also at x is 3. So what's the value of the function of this guy when x is 3? Well, we can also use this guy. This one's easier because they intersect. They touch at the same point. Y is equal to 3. Okay, so let's say this is 3 over here. And we know that, let me just put ticks. We know that at x is 4, this guy has a 0 also. So it'll look something like this. Parabola, right? So it'll look something like that. Okay, so just a sketch. We want to rotate it about the y-axis. So either we use the shell method or the washer method. The washer method would be more difficult because the curve changes, the outer curve changes up here. So we probably want to do the shell method, depending on the choices. Okay, I've done this problem before. They use the shell method. Okay, so how to do the shell method? Well, we have to draw a cross-section parallel to the axis of rotation that has height h, and then we draw some other representative r, that's the distance from the axis of rotation to this cross-section, okay? Volume is 2 pi integral r h dx. What are limits of integration? Well, we're integrating in terms of x, so it's from 0 to 3. What is r? That's this distance. That length is x. What's h? This length is the parabola minus the linear. So parabola minus the linear. Okay, so we can simplify. Inside would be 3x minus x squared, and we can distribute the x. Okay, that should be E. Let me double check the answer. Yep, that's correct. Okay, that's how we do this one. Okay, sorry, I don't know if the video jumped. I had to pause real quick. All right. Limit as h goes to 0, ln of e plus h minus 1 over h is, well, if you peek at the choices, it's talking about derivative. So that you should be able to recognize that this is the difference quotient, limit definition of the derivative. This is just, instead of 1, it's same thing as ln e. So maybe this will help you realize that this is just f prime of e, and the function is f is ln of x. Okay, we're evaluating the derivative of ln x at x is equal to e. So that is A. Position of an object excuse me, attached to a spring is given by this guy, where t is time in seconds. In the first 4 seconds, how many times is the velocity of the object equal to 0? So there's 2 ways to do this. You can graph this, and we know the derivative of this is equal to 0 when this guy has relative maximum min. Okay, that's one way to do it. Another way to do it is, well, you can plug this as y1 in your calculator. y2 would be y prime of t, and we see where that is equal to 0 in the first 4 seconds. So I'm going to do that instead. Okay, so I put it in Wolfram alpha. Okay, so we're interested when it's from 0 to 4. Okay, so how many times does it cross 0 when in the interval 0 to 4? That's, you just count 1, 2, 3, 4, 5, 6. So it crosses 6 times. So meaning the velocity is, so that the graph I showed was the velocity, and we showed it was equal to 0 6 times. So that should be D. Okay. Let f be the function given by f is cosine 2x plus ln of 3x. What is the least value of x at which the graph of f changes concavity? The quick way to do this is, well, first of all, when it talks about concavity, a good idea is to find the second derivative. Okay, so we're going to put this as y1, and then y2 would be n derive of y1, and then y3 would be n derive of y2. Okay, that's to get the second derivative of f. Okay, and then you can graph that to see where it changes sign, and that's where it changes concavity. Okay, or, because my calculator on my phone doesn't have that capability, I quickly found what f double prime is. So I have to find what f prime is first. That's negative 2 cosine 2x plus 1 over x. F double prime would be minus 4 cosine 2x minus 1 over x squared. Okay, so let me graph in my calculator and show you. Okay, so this is how it looks. We're interested in when it changes, when f changes concavity. So that's when the second derivative changes sign. And the first guy to do it is 0.931523. That's what I wrote there, okay? And that is B. Let f be continuous on the closed interval negative 3 to 6. If f of negative 3 is negative 1, f of 6 is 3, then the intermediate value theorem guarantees that. Remember what that says? Well, let me just even sketch it here. F of negative 3 is negative 1, somewhere here. F of 6 is 3, is up here. It says f is continuous. That's an important condition. Because it's continuous, and because one term is negative, one term is positive, there must be at least 1 0 because it's continuous, right? Because, so it could go like this, or it could go like this, or it can even oscillate a few times and go there. So it has to cross the x-axis at least one time. So that choice is, I believe, d f no. Okay, yeah, that is right. So it works for the x-axis, but it could work for any value between -1 and 3. So this is fine also, okay? That was just an example. That it could be the x-axis or it could be axis 1, same thing, right? Since it's somewhere there and it's continuous, it has to cross that line at least once, okay? Same thing. So the intermediate value theorem says, let's move on. X is between 0 and 4, which is the greatest value of x such that this integral is greater than this integral. Okay, so I would just start evaluating this via fundamental linear calculus, okay? So let's find the antiderivative of both sides. This side is just, they're both powerable, so this side will be t cubed over 3 minus t squared, evaluate from 0 to x. This side would be t squared over 2, evaluate from 2 to x. We plug the upper and lower limits in. This would become x cubed over 3 minus x squared. This guy would become x squared over 2 minus 2. So here I would just use a calculator to graph this and find the point where this guy is bigger than this guy. So let me show that. So it looks something like this. Okay. The red is this one, the blue is this one, okay? So we see that the red is bigger when, actually, did I graph this right? X cubed over 3 minus x squared. Okay, so we would just find this, whoop, not find roots. Why is my calculator not doing the find intersection? So at this intersection, x is 1.38, that's why I wrote down there, okay? So we see that at this point, okay, it's always greater than the blue. The red is always greater than the blue. I got confused, like, of the opposite way. Okay, sorry about that. So this guy is always bigger than the blue. You can see that. And it goes until this crossing, which is here, okay? After that, the red is underneath, right? It's smaller. So that's why x is this guy, okay? So this is the closest answer. Okay, if dy dx is 1 plus ln x times y, and if y is equal to 1 when x is 1, then y is equal to what? Here, what can we do? We can do separation of variables to solve this differential equation. So let's move all the y's to one side, all the x's to the other. dy over y is 1 plus log x dx. Okay, now we can integrate both sides. Left-hand side would be log of y. Right-hand side would be x. Okay, so this is Calc BC. You should know how to find the integral of ln. If you don't remember it, it's by integration by parts, which you can quickly do. Okay. Otherwise, if you do remember, it's just x ln x minus x. Okay. So plus some constant c. We can solve y. Y is c e to the x plus x. Okay. So this and this would cancel, right? So it's just x log x and the exponent, okay? Now we have when y is 1, x is 1. So 1 is equal to c e to the 0, because ln1 is 0. So c is equal to 1, okay? So our y is just e to the x ln x. This is our particular solution. Choice E. Okay. This guy is by integration by parts. Okay, you should be able to recognize that. I'm just going to do the tabular method. We choose a u as x squared, because that one, if we differentiate continuously, it'll eventually go to 0. Okay, dv is what's left, sine x. We integrate just as many times. Okay, we go diagonally and we alternate sign. Okay, so it's just, we follow the arrow, it'll be minus x squared cosine x. We follow the arrow, that'll be plus 2x sine x. Follow the arrow, that's plus 2 cosine x plus c. That's choice C. Okay. Let f be a twice differentiable function such that f of 1 is 2, f of 3 is 7, which the following must be true for the function f on interval 1 to 3. Average rate of change is 5/2. What's average rate of change? That's just f of 3 minus f of 1 over 3 minus 1. F of 3 is 7, f of 1 is 2. Bottom reduces to what? 2? 5/2? This is correct. Average value of f is 9/2. We only have 2 points. We don't have like a function where we can find the integral, so not enough information. Average value of f prime is 5/2. That's right, because the f prime is the rate of change, right? So the average rate of change is just this again. So good. So it's 1 and 3 only. Okay. This guy, you should recognize as, we can integrate this by partial fraction decomposition. So we can rewrite it as 1 over, so this guy we can rewrite as a over x minus 1 plus b over x minus 3. Multiply both sides by the denominator. 1 is equal to a x minus 3 plus b x minus 1. We plug in easy numbers like x is 3, y, this would go away. So we get 2b is 1, or b is half. Plug in x is 1. Why do we do that? This would go away. We get negative 2a is 1, or a is negative half. Okay, so now we can rewrite this as a, which is negative half, times 1 over x minus 1. Okay, b is positive half, times 1 over x. Oh, did I write it wrong? So this should have been x equals minus 3. Sorry about that. Okay, the a should be right. The b, let me double check. The b would not be correct though, because when we plug in x is negative 3, this would go, we get negative 4b is 1, so b is negative 1/4. Sorry about that. So this guy would be actually, a would not be correct either. A would be what? 4a is 1, a is a fourth, okay? My bad. So this is the one problem I did not work out beforehand, okay? Or one of them. So this is 1/4 times 1 over x minus 1 minus 1/4 times 1 over x plus 3, okay? We can even factor out the 1/4. Okay, so these are just logs, right? So it'll be log x minus 1 minus log x plus 3 plus c. And combine the logs. I think we need to do that, right? So it'll be 1/4 log of x minus 1 divided by x plus 3 plus c. 86 is A. Okay, sorry for the little mistake over here, just because I copied it wrong. Okay. Base of a solid is the region in the first quadrant enclosed by y is 2 minus x squared and the coordinate axes. If every cross-section of the solid perpendicular to the y-axis is a square, the volume of the solid is given by what? Okay, so let's sketch what's going on. It's always a good idea. So this guy is a parabola that opens downward. Okay, so we know it looks like when x is 0, y is 2, right? So it looks something like this. Okay, so it's in the first quadrant, so we only care about this side. Okay, so this is our region. Okay, let me shade it a little bit. Cross section perpendicular to the y-axis is a square. So this guy would be a square here. this guy would be another square here, something like that, okay? Perpendicular to the y-axis, not x-axis here, okay? So we need to integrate in terms of y. So the volume would be what? It will be area of the cross section. That would be, if we call it the length S, okay, it'll be side square, that's the area of a square, right? And then some small height dy, and we integrate it, okay? So what is S? What's this length here? That's just, well, we can write this as x in terms of y, right? So it'll be x squared is 2 minus y. So x would be plus or minus square root 2 minus y, which corresponds to the two branches, okay? This one would be the plus, okay? So it'll be plus square root of 2 minus y, but we square it, so technically it wouldn't matter mathematically if it's plus or minus, but this branch would be the plus, okay? So it'll be 2 minus y dy. And we integrate it from, we need the limits in y, so it'll be from 0 to 2. Okay, and you could plug this into, actually, you don't have to find the final number, as you could just plug this into your calculator. This guy, B. Okay. Okay, 3 more problems. Let's finish this up. Okay, let f be integral from 0 to x squared sine t dt. At how many points in a closed interval, 0 to square root pi, does the instantaneous rate of change of f equal the average rate of change of f on that interval? So what's the instantaneous rate of change? That's f prime. What's the average rate of change? It'll be f of square root pi minus f of 0 over square root pi minus 0. Okay? So this side you can find with a calculator. Okay? F prime, what's f prime? We need the derivative of this guy. So we need the fundamental theorem calculus and the chain rule. Okay? So the left-hand side, would be sine of x squared times 2x. Okay? And this value over here, well, you can put it in your calculator. I did not do it, so let me do it real quick. Okay, so f of negative pi would be integral from 0 to pi sine of t dt. Technically, you could do it by hand, but by calculator, you should get 2. When f is 0, integral from 0 to 0, that's no error, so that's 0. So it'll be 2 over root pi. Okay, so we want to set these equal to each other. Okay, so once again, we can graph it, or you can do this guy minus this guy is equal to 0 and find the roots, okay, in this interval. So let me do that real quick now. Okay, so I graphed this guy and this guy. So obviously this guy's the constant, okay? So we want intersections between 0 and root pi. Okay, root pi is like 1 point something, I just calculated. So we gotta be careful whether to include that or not. I'm not sure off the top of my head right now. So let's find intersections. So there's this one for sure, okay? Because that's between 0 and root pi. How about this one? This is less than that 1 point something, so this is included also. This next one would be above that, so there are 2, okay? So 888 should be C. Let me confirm that with the key. Yes. Okay. If f is the antiderivative of this guy, such that f of 1 is 0, then f of 4 is equal to what? Okay, so f is the antiderivative of this. So f, let me write it here. Let me just start in this corner. F of x is the integral of x squared over 1 plus x to the 5th dx. Okay? This is what it says. So we want f of 4, and they give us f of 1. So we can't solve this differential equation using the techniques you know, so you got to be a little smarter. So what if we make it a definite integral? Okay, so if we say the integral from 1 to 4 of this guy. Okay? We know that f is the antiderivative of this, so it would be f of 4 minus f of 1. Okay? And we know that f of 1 is 0. So f of 4 is just this integral, which you can put into your calculator. And if you do, that is, what's the answer that I got? 0.37 something? Yes. So it'll be that one, okay? That's how we do that one. And the last one, this is an application problem. A force of 10 pounds is required to stretch a spring 4 inches beyond its natural length. So for springs, I remember it's F is equal to kx, something like that. So force of 10 pounds, k times 4, okay? So k is equal to 5 over 2, okay? So we might need that, so I quickly did that. Assuming Hooke's law applies, okay? How much work is done in stretching the spring from its natural length to 6 inches beyond its natural length? Work is force times displacement, okay? So force, we know it's 5 over 2x, or force dotted with displacement is the more accurate term. But anyway, so force is 5 over 2x. So we want to simply integrate the force. So let's over displacement, okay? So the limits of integration are from 0 to 6. When it's natural, 0, stretch to 6. That's what it's asking, okay? So this is integral from 0 to 6, 5 over 2x dx. So that's 5 over 2. Oh, you can just plug this into your calculator, actually. So I'm not going to write it out. Let me do that real quick. Let's hope I did this right. I think I did. Let me just check with the key, actually. Yes, okay, I did do it correctly. So when you integrate this, you should get 45. Just plug this into your calculator because this is calculator section. Okay, and that's it for this 1997 exam multiple choice portion. Hopefully this was helpful. Please like the video if it was. And also please subscribe to look out for the 1998 exam.